In this video, I'm going to derive the following algorithm to fix this parity error. Before I even begin, I need to mention that for those who have not seen the derivation on the standard algorithm, need to go see that video I made first. Otherwise, you will be lost in this video because I build directly off of that video onto this one. The reason is, this algorithm's derivation is almost identical to the standard algorithm. They actually only differ slightly, to believe it or not. Similar to how I took the standard algorithm and I separated setup moves from the main portion of the algorithm for which we need to derive, the first two and last two pieces are setup moves. And the central piece is the one for which we're ultimately going to need to derive. But we already know the effect of the entire algorithm. It swaps these two edge cubies, and similar to the standard algorithm, it swaps these two 1x2 center blocks in the top center. So now what we're going to do is omit the outer setup moves first. So then we apply these setup moves and the innermost piece to the cube to see what we have to build from. Unlike the standard algorithm, which the outermost setup moves took care of setting up the centers and edges simultaneously, the outermost setup moves for this algorithm only set up the centers, because the two individual edge cubies in the same composite edge are already swapped. Hence, we need to understand how these setup moves work. To do this, we can start off with a clean cube and execute the outermost setup moves. These two center blocks are set up just as shown here, where these two are swapped, and if we set them up that way, then the black will swap with black. And this edge right here, this composite edge, is still together, and when we swap them with each other, and we then undo these outermost setup moves, we still have all edges paired, and therefore we have a success. So from this, we're going to remove these setup moves to see what our ultimate goal is. The result is a little bit different than the standard algorithm in that we only have one edge cubie by itself in the top left front slot, and we have the other one up diagonally opposite to it, for which the two centers that were swapped initially before these setup moves were removed are next to that one. So how does the setup move R2 work? Well, R2 takes this edge cubie and puts it down here. So that takes care of the two edge swap in the same composite edge. And as for the centers, the red and black were the ones that were swapped. If I go ahead and add the setup moves back in, you see the red and black. That red and black is moved down here where the two centers are swapped with each other. So these setup moves are pretty intuitive to understand. Hence, this is the main objective we need to accomplish, is this. Or, in algorithm itself, is this. So, let's begin. Here is the commutator which was formed in the video on the standard algorithm. But this is what we have, and this is what we're going to build directly from. applying this to a cube, it swaps 3 1x3 blocks in a different manner than before as far as the order is concerned, but the slots in which the 3 1x3 blocks are in are the same. The slot was here, here, and here. What we first need to look at is the algorithm which we want to ultimately derive, which is a pure quote-unquote edge flip algorithm. Every face turn of 180 degrees is U2. This is something we need to keep in mind as we derive our algorithm, and we're going to have to do a few extra moves more than necessary to accomplish this parity task, but at the same time we'll be rewarded with having an algorithm with all U2s. At this point, however, I'm going to go ahead and erase that. We have all U2s right now, so we're perfectly fine, but we have to keep it that way. So, again, looking at the 4x4 cube, what we need to do, again, is move all 3 1x3 blocks in the same slice. And again, we're going to put them all in the right slice, but this block right here is affected as well as this one, but we need to put this here without using F2. But how do we do that? How does it work? What we have to first do is move this and this both down like this, and then we rotate this so that this is on top of them. But of course it's not going to be like this. It's going to be with setup moves, so it's all preserved. So from what we have, we're going to have to apply a setup move. In order to move everything in the right slice down, we're going to have to move the R slice down, or R prime. By doing that, as you can see, those two move down, and this slot is still affected. Applying that setup move here, R prime, and then R, this is what we have. And obviously at this point, in order to put this 1x3 block here, all we need to do is the 180 degree rotation of the top, or U2, as setup moves. Adding this in here, we see that we still have all the U2s, which is our ultimate goal, so we're doing a great job. But we don't want to use too many moves, so we have to try to finish this as soon as possible with having all U2s. So, at this point, notice that these two are connected, as in solved. So that if we just do a quarter turn slice, R prime, then again, two edges are swapped, as well as two 1x2 center blocks, a familiar sight. So going and adding that into what we have so far,